start. Yeah, fine. So welcome back, guys. So today is the 100 days challenge of day 5. So in this day 5 now we are going to see what is the laws of motion. That about mainly we are focused on the free body diagrams, which the questions mainly asked in NEET competitive and JEE examinations. So let us go into the topic. So first we'll see what are the type of forces. Like if we see the types of forces, contact force, either it is non-contact force. These are the two types will be there. So under contact force there is a normal reaction, the second one is tension, third one is a spring force, and fourth one is a friction. And when we see about the non-contact, it is a gravitational force, electrostatic force and magnetic force. So these are the forces which we are going to study in the 11th and 12th classes of the physics. So on the common force is nothing but the weight. So whenever an object is there in earth's surface or whatever in earth, so weight will be acts. It's due to gravity. So we'll see what is the first thing, the gravitational force, that is weight. So it's because of gravity the weight acts. The definition is the downward force due to the gravity acting on a body. For example, if I take a body of mass m, okay, so the direction of the force will be always towards down, like direction,
What's the center of the earth?
yeah, direction is always down. Okay, so whenever if we take a body like this in inclined plane also, this is mass m, okay, then also I should take a weight towards down, like I should not take in this direction. There is a wrong thing and this is the correct way of representation of the weight. So weight is nothing but mass into gravity, okay, it's due to gravity, right? Next, the formula is W is equals to mg, where m is the mass of the object and g is the acceleration due to gravity, which is 9.8 meter per second square. Next one is the normal force. So definition is the perpendicular contact force exerted by a surface to the support the weight of an object which is on the resting position. Like for example, no, if we have taken the mass of an object in the earth, so when I consider a mass, obviously the weight will be there. But if I talk about the normal, no, there should be a surface. There should be a surface. So if I take a mass m, so obviously the surface, I mean normal should be perpendicular to the surface. This 90 degree and this will be my normal. When I consider these kind of things, no, like a mass which is in an inclined plane, so this is my mass, so I should consider my normal force exactly perpendicular to the surface, right? So always perpendicular to the contact surface. This is the main thing you should remember, always perpendicular to the contact of the surface, and this one towards the earth, that is center of the earth, okay. These two things you can keep in mind when you are talking about the weight and the normal reaction, I mean normal force. Next one is the tension force. So when I talk about the tension, no, it's always away from the body, like a pulling force transmitted through a string or a rope or a cable. So these are the things, like if a string is there or if a rope is there, string or a spring or anything, in this kind of things a tension will act. For example, like if I take a body mass m and which is tied with a rope or a string or a chain, anything, okay, which is hanging in the surface, we'll say. In this we know that weight is acting, that is mg. Can you say in this in this figure a normal force is acting or not? No, right? Because there is no surface, there is no contact with the surface. So if I see here, a tension force is there because this is a rope or a chain or cable we consider. So whenever I need to mention a tension force, it's always away from the body, away from the body. So the arrow mark should be away, not towards the body. Like if I keep the arrow mark like this, no, it is towards the body. I need to mention the tension force which is away from the body. So always away from the object along the string, okay, along the string. And one more thing you need to remember, whenever, like if this is the case, like at Woodward, this is mass m and this is capital mass, small mass m and capital mass m, okay. If I see here, no, a string is same, a cable or a string, same for the mass small m and capital M. If I consider a tension for this one, it is T, away from the body, and for this also same tension only, T. If string changes, tension changes. The thing you should keep in mind, if string or anything like cable, rope or cable changes, the tension changes. So I will show you a diagram here. This is the one case where small mass m and capital mass M is there. In this case, string is same, which provides the tension, right, T. When I take like this, M1 and this is M2 and this is M3, okay. In this case, no, when I see M1 and M2, the common string is acting for both of them, but for M1 and M3 there is another string which is connected with M2. So there are two different strings, so the tension will be changing here. See, this is tension T. If I take the tension for M2, again T only, but for M3 and M2, no, this is T1 or T dash anything, and this is away from the body. See, same tension will be acting, no, in the string for M2 and M3. So one is T1 away from the body for M3 and one more T1 is away from the body for M2. Am I correct? See, these are the two cases of the strings or tension force, we will say, tension force. So the next one is the frictional force. So definition is the force that opposes the relative motion or a tendency of a motion between two surfaces in contact. So when there is a contact force, no, like when there is a contact force for the object, if I am pushing or pulling the object, if there is a rough surface, obviously tension will be frictional will be acting, okay, which is opposite to the giving force, yeah, motion we can say. If for example this is the body M, if I am pushing the body like this, so let me consider this is the rough surface, okay, rough surface. So the frictional force will be acting opposite direction, it is opposing force we will say. So this is opposing force, okay. So the formula is F is equals to mu n, where n is the normal and mu is the coefficient of friction, okay. I can find n for this, no, like this is the m, obviously weight is there, that is mg. So if I draw perpendicular, this is n, okay. So guys, keep in mind, like n is equals to mg, we can get it. If like for all the cases n is equals to mg is same,
Inclined.
Okay. In inclined position, if I take this is m, this one will be my mg, right, and this one will be my normal, this weight and this is normal. So I will make a diagram here. This makes an angle theta and this one is m and this one is my mg and this is my normal force, where n is not equals to mg. Okay, not equals to mg. For this I need to take the vector components. Yeah, wait a minute, I'll tell you how to take it. Okay, see, draw 8 lines like this. Okay, whatever angle mentioned like this, no, same exactly same angle you mention here. So give 1 and again you mention like in the alternatives, theta, theta, again theta here, theta here. Okay, now if you see here, no, this is my mg, right? This is my mg. If I take this one, this will be my, like theta is near to that, then it will be cos theta, right? Mg cos theta, and this one will be my mg sin theta. Okay, now I can say easily, no, this one will be my, exactly, this is mg cos theta, and this one will be my mg sin theta. So n is not equals to mg, so in this case n is equals to mg cos theta. So always n is not equal to mg. It may change when it is in the inclined planes. Okay. Next thing is applied force, like the force which we are applying, like for pushing or pulling, those are the applied force, like external force we'll say. Okay. Next is air resistance or a drag force, a type of frictional force acting opposite to the direction of the motion through a fluid. So when I take an object and if I keep in a fluid, no, it will try to resist. What is the force we'll say? Buoyancy force, no? Yes or no? Buoyancy force, like which is opposing my object, right? If the buoyancy force is there and weight of the object is there, if weight of the object is more than buoyancy force, what will it will sink. If buoyancy force is more, it will float. Yeah, it will float. Next, spring force, the restoring force that a spring exerts when compressed or stretched. The formula is F is equals to minus kx, where k is a spring constant and x is the displacement. Whenever I stretch a spring, like initial position to final position, it's going, that x is known as displacement of from equilibrium. If I am compressing, no, like from initial to final, that displacement is also known as x only. For both, like like compressed or expander, both are same only, like for x.
But y minus?
Which one?
F minus k.
Minus kx. Why it is minus? So it is restoring force, no? Opposite direction. That's why it is minus. Fine. First one, like we'll see the Newton's law and then we'll go for the free body diagrams. Okay. So Newton's first law of motion, or law of inertia, we'll say. So the definition is an object remains in state of rest or uniform motion in a straight line unless acted upon by an external unbalanced force. So if a person is standing, okay, if any force externally someone is applying on the person, until that he will be in rest. Or suppose a person is running or any object is going, okay, in a motion, until and unless an external force is acting, it will be in the same motion. That's the first law says. Okay. Second thing is, like the rate of change of momentum of an object is directly proportional to the net external forces applied. So from this law only we got F is equals to ma, that force is equals to mass into acceleration. So these are the laws which we are going to use in the free body diagrams. Okay. Next one is the third law, like it's the most common law in day to day life, no? Like for every action there is equal and opposite reaction. It's not like the Newton's law is applicable for, like third law, it's applicable for life also, no? So action and reaction force acts on a different bodies. Like second point is implication in free body diagram. If one body exert a force F on another, the second body exert a force minus F. Like it's equal and opposite force, right? So if a body exert F, if the body should be in rest, what is the force should be exert? Minus F, like equal and opposite force. Now we'll go for the free body diagram. So whenever you are drawing a free body diagram for an object, no, you need to look out whatever force we have discussed here. For example, if I take an object which is like this, okay, which is like this, what are the force exerts in this?
Weight of the body,
Weight of the body first,
reactionary force.
this is mg, I'll consider this is m, okay.
Normal.
How many normal forces are acting now? Like if I see there are two surfaces, then two normal forces, one will be in this case, no, this is n1 I'll consider, and this one will be my n2. So when you are drawing the free body diagram, no, after that, like draw simply, it's a point mass, consider it's a point mass and draw the diagrams. So this is mg and this one will be my n1 and this is n2. So is there any other forces are acting? No, right? So only the normal n1 and n2 and the weight of the object. Suppose if I take an object like this, this is mass m,
Downward mg,
downward mg, fine. Next,
upward is in upward reactionary force.
upward what reaction force is there? No, right?
Then levitate
It's
tension.
nothing, like it's in this, like when we take an object, no, suppose I am not hanging this, it's like this, what is the force acting? Only mg, right?
But it cannot levitate.
Like if a person is jumping, what is the force acting? Only
mg.
mg, okay. If a person is jumping from a building, if an object is jumping like this, but it's not landing, until that only mg is acting. Suppose he landed, carefully he landed, okay. Now this is mg is acting, always mg will be acting. Now one more force is also there, that is n. So in this case I can say n is equals to mg. So where the person will be in the rest position. Then we can take an object like this, m, and this is m2, m1 and m2. Now what are the forces?
Tension.
One is tension,
mg tension.
this one tension, same tension, no, same string, same tension. This one will be m1g and this one will be m2g. As of now I am not considering whether m1 is greater than m2 is greater, like I am drawing only the free body diagram. So let me take the point mass, this is t1, t, and this is my m1g, this is my t and this is my m2g, okay. So I can equate, no, like if both t are there, m1g equals to m2g, if masses are equal, if it is in rest, it will be same only, right? Okay, let's take the question, determine the tension T1 and T2 in the string. First what I should do, take a mass and draw it a point mass, then what are the forces are acting I should find. Here tension is given, like it's a string, no, it's attached with a wall. So one string, like one tension is T2, another tension is T1. So T1 is making angle 60 degree. First I need to take a vector, okay, I can't solve directly, I need to take a vector and then I need to equate it. So after taking vector, no, like take x and y equilibrium condition and then solve the problem. Let me solve the problem here. So this is 60 degree, no, tension T1, then this one will be my T1, like 60 degree near to the axis, then this one will be cos 60 degree and this one will be my T1 sin 60 degree, okay. Consider this figure is in equilibrium. Now summation x is equals to 0 and summation y is equals to 0, okay. So in x axis and y axis we will consider. Now if I see in x axis, no, this is T2 equals to T1, T2 equals to T1 cos 60 degree. Now if I see in y axis, this one is root 3g,
kg.
so T1 sine 60 degree, which is equals to root 3g. So these are the two equations I got from the figure. Now T2 is equals to what cos 60? It is 1 by 2, right? 1 by 2. I'll keep as it is, or let me solve. T1 is equals to 2 T2. Okay. Now this one T1 sin 60 is root 3 by 2 is equals to root 3g. Root 3 cancelled, and T1 is equals to 2g. So let me take g as 10 meter per second square approximately. Okay. So T1 will be equals to 20. What about T2 now?
T1
So T1, that is 10 divided by 2, which is nothing but, I mean this is 20, no, 20 divided by 2. So T2 will be equals to 10. So this is 10 Newton and this is 20 Newton. So these are the answer for the tension in the given strings, 20 Newton and 10 Newton. Yes, we will go for the next question. Okay. So could you solve, like, you try this problem? Try this problem, guys, and give answer. I will explain this one. Okay, fine. Now it's visible, I guess. Try this problem now and give answer in the comment boxes. A pulley and a string shown in the figure are smooth and of a negligible mass. So no need to consider what is the mass in the string. For the system to remain in equilibrium, the angle should be equals to. So directly I can't solve. And one more thing, if you see here, string is changing. String is changing here. Our rope is changing here. From m, small m to root 2 m, same string, and it is again making an angle and same rope only. So totally it is same rope only. It's not changing. Like string is not changing. So tension will be same only. If I consider T here, T everywhere. Okay. So in today's class and tomorrow's class, we totally solve with the free body diagram and the questions. I'll give you a hint here. Okay. Fine. So if I see here, this is my mg and this is my t. So here also t will be there again. If I see here, this is my t, and this is also tension t. So this is mg again, and this one will be root 2 mg. These are the things we can write. Which one? Root 2 m. Root 2 m is mass. Root 2 m is the mass. Here 1 m, here root 2 m. Okay. Now this is angle theta, right? And this one will be again same angle theta. Okay. Now what I can say here, this is theta in the sense, this one will be, I will draw here. This is root 2. Okay. This is root 2 mg. It's making an angle theta in this case. Now this one will be my t cos theta. Then this one t cos theta, this one will be t sin theta. T sin theta. What about this one? For this one, again t cos theta in the vertical direction, t sin theta in the horizontal direction. So t sin theta in this direction, t sin theta again plus t cos theta. Like 2 times it's adding, no? So t sin theta, like it's in equilibrium condition, no? It's unequal forces are acting. I can cancel it out. So I can say that 2t cos theta, which is equals to root 2 mg. Right. So now from this, either this case or this case, no, I can find what is t. T is nothing but mg. So I can take this equation and substitute here 2 into mg into cos theta, which is nothing but root 2 mg. So mg cancelled out. Cos theta will be equals to root 2 by 2. So I can say that cos theta is equals to root 2 by root 2 into root 2. So root 2 cancelled out. So cos theta, which is equals to 1 by root 2, where theta is nothing but cos inverse of 1 by root 2. It is 45 degree. So each 45 degree. This is 45 degree and this is 45 degree. I'll erase it this here. This is 45 degree and this theta is also 45 degree. Okay. So one more question is there for today's class. Expand this so that you can see the diagram. Okay. So give answer guys for this question. In the arrangement shown in the figure, what be the mass of a block A so that the system remains at rest, neglect friction and mass of the string? So I can consider like this, no? This one inclined plane is there, where it makes an angle 30 degree and there is a mass, this is 2 kg and this mass is again 2 kg. Now I need to find what is the mass which is hanging in this direction. This mass I need to find. Okay. If I see here, no, this one will be my weight, that is 2g, and this is my normal, right? This is n. Now if I take the components, we know before we have seen like how to take the components. So better draw 8 lines like this, and wherever the angles you are seeing, mention the angle same. So theta alternative you write. So this is my 2g cos theta or sin theta? Cos theta, that is cos 30, no? 2g, yes, 2g cos 30 degree, and this one will be my 2g sin 30 degree. Okay. So if I see here, no, tension is acting, T. Here also T will be there. Again if I see here, tension T. This is T, again here T. One more T will be here, no, tension here. Okay. Now if I consider this one, no, T will be equals to 2g. This is 2 kg, no, so mg, right? Weight is out downward, mg, tension 2g. I'll keep the tension as it is. Now this 2g sin theta and this tension will be equal, 2g sin theta plus T. 2g sin theta plus
P
equals to
T plus 2g.
2e plus 2g. Okay, I'll give this equation. Solve it. Almost we completed, no, only the equation but is left out. So T equals to mg we have taken, and this one is 2g sin, here this is string is changing, no, this is T1, 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 T1. Am I correct? String is changing. It's not like here I can take T, this one either T1 or T2, whatever it is. Okay. 2g sin theta, no, sin theta sin 30 plus t equals to T1. T1. I know what is T1, no? This is mg. The mass I need to find it. So 2g sin theta I mean sin 30 is 1 by 2 plus t is nothing but 2g, right? 2g equals to mg. G cancelled out, and this 2 and this 2 cancelled. So m is nothing but 3 kg. 2 plus 1 is 3 kg. Where it is? Wait a minute, I'll on it. Okay, guys. Okay, the answer is 3 kg, right? Okay, we'll continue with the next class. Bye, guys.